As an example, let's try and create the Laurent series of a certain function around the origin. And the function that we're going to consider is f of z is equal to 1 over z and then times z minus 1. So we're going to develop this function as a Laurent series around the origin. Now, if you take a look at where this function blows up, it blows up at the origin and it blows up at the point 1. So in the complex plane, the points to avoid are this guy and that guy over here, 0 and 1. So if we translate that to our donut-shaped region, it basically means that we have two sorts of regions. We have one inner region over here, where the modulus of z is basically lying between 0 and 1. So the radius of our inner donut shrinks to 0. That's a pathological case, but still perfectly fine. So this is the first region where we want to develop the function in the Laurent series, which stays clear of these two problematic points. And then the second region is the outer region over here, where the magnitude of z is actually bigger than 1. So again, this is a pathological case with now the outer radius going all the way towards infinity. But again, you can apply the same things. So in both of these donut-shaped regions, we have the situation that our function is holomorphic, and therefore we can develop them in the Laurent series using the formulas that we've seen before. Although using the exact formulas based on the contour integration would be rather laborious. It's possible, but I wouldn't recommend it. Rather, what we can do is look at this function over here and see if we can be a little bit more clever about it to find the Laurent series. For example, by making use of stuff we already know, like the complex valued geometric series, for example. So pause the video and see how you need to massage this expression over here to use the geometric series to write the Laurent series for that function in both of these two regions. So the geometric series is for the function 1 over 1 minus z, which is almost over here, just with a minus sign. So actually what we can do is we can, in this case, write f of z as minus 1. And then we have the 1 over z, which is left over, of course, over there. And then finally we have 1 over 1 minus z. And for this part over here, we know what the series expansion looks like, and we can safely apply it because z in magnitude is smaller than 1 here. So basically what we have is minus 1 over z, and then our geometric series m from 0 to infinity, z to the power of m. What this basically is if m is equal to 0, it's minus 1 over z, and then we have minus 1 minus z prime, etc., etc. So this is the Laurent series of our function. And again, because we have this guy over here, this clearly shows us that there's a problem at the origin, because this is where the function blows up. So this encodes the singularity at the origin. Cool. So now you know how this is done. Perhaps you need some extra time to try and do something similar for the outer region. In that case, just pause the video and try something similar. So in the outer region, we cannot really do that because there the magnitude of z is bigger than 1. So we can't really apply this formula over here since z is bigger than 1. However, in this region, 1 over z will be smaller than 1. So the trick here is to start from our original function and go and divide numerators and denominators by z. And in that case, we will be able to apply this modified geometric series. So now we can write that f of z is 1 over z. So this is the 1 over z over there. And in the leftover thing, 1 over z minus 1, we're just going to divide both numerator and denominator by 0. So we have 1 over 1 minus 1 over 0. So this becomes 1 over z squared, and then we have 1 over 1 minus something, and that something is smaller than 1 in magnitude. In that case, we can apply the geometric series. It's going to be 1 over z to the power of m. And if you write down term by term what this thing means, it's 1 over z prime plus 1 over z cubed, and so on and so forth. So this is the Laurent series in the outer region. So obviously these two look completely different because there's a singularity at 1 that separates these two regions. So therefore you need to change the Laurent series representation also.